begin a new chapter, that is heat. Now we will study what is meant by heat. Heat means a form of energy. Now with the help of examples we will study in detail about heat. Now here, as I told you, heat is a form of energy. Now here we people already studied that electricity flow from higher level to lower level. In case of electricity, it flow from higher level to lower level. We studied that heat is a form of energy. Now electricity flow from higher level to lower level. Similarly, water flows from higher level to lower level. These examples we had already studied. That means electricity flow from higher level to lower level, water flow from higher level to lower level. Similarly, we can say that heat energy also flow from higher level to lower level. Now, how it is flowing, let us see. If we are keeping two objects, this is one object, now this is the other object, both of them in touch, that means in contact with each other. So we can say that this body, this is one body, this is the other body. Now we can say that this body is having more heat, we can say. Or we have heated it. So we can say that this is having more heat now. At the same time, this is having less heat. So here we can say that when we are comparing the heat, this is having low heat, this is having high heat. More heat we can say, or we can say as high heat, this is having low heat. So such a two bodies we kept in touch with each other. So we can find that which body is having more heat, from that body heat will transfer to the body which is having less heat. Then till how much time heat flow will take place? Till both of them are getting equal heat. Till both of them are getting equal heat, till the time there will be heat transfer. Heat transfer, its meaning movement of heat from the body which is having higher heat to the body which is having lower heat. Now here high heat body, low heat body, like that we won't say normally. We are saying it as hot body as well as cold body. Hot body as well as cold body. Normally we are using the term hotness as well as coldness. Hot body has hotness and cold body has coldness. Now, so what all things we had studied now? Here two bodies we have kept. One body is having high heat, other body has low heat. So we can say that this body has more heat, this body has less heat, or we can say this body is a hot body, this body is a cold body. Now both the bodies, if we are keeping in touch with each other, we can find that heat transfer from hot body to the cold body will take place. Now the question is here, till when it will be flow? That means the heat transfer till how much time will happen? That is till both the bodies are having or are getting equal heat. Till the time the heat flow from hot body to the cold body will take place. Then both of them will attain equal hotness. Now we can say that how much, now we understood that both of them are having equal hotness. But for measuring that, now how much hot is there, how much coldness is there, for measuring that, we are using a quantitative measure. We can say that a quantitative measure we are using for understanding how much hot this body has, how much hot this body has. So we can say that here this quantitative measure of degree of hotness or coldness is known as quantitative measure of degree of hotness or coldness of a body is known as temperature. Is known as temperature. Now hotness, we can say normally how much hotness your body has, or this object is very hot, like that normally we speak. But at the same time, how much hotness is there, that degree of hotness or degree of coldness, for finding that we are using a measure. That measure is known as temperature. Now we can say that temperature always we measure in degrees. Now always temperature always we are measuring in degrees. Now we can say that what are the unit of temperature. Unit of temperature, now three types of unit of temperature is there. We can say that Celsius, then other one we can say that Fahrenheit, 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 and we can say that Kelvin. Kelvin writing time you have to take care that K should be always in small letter. Name, Kelvin name also there. So Kelvin name come, then we have to write in capital letter. But at the same time unit Kelvin come, then that should be in starting letter should be in small letter. So here we can say that these are the units of the degrees of temperature. Units of measuring the temperature. So there are three units of measuring temperature is there. Celsius is the one, second one Fahrenheit, Kelvin is the third one. So we can say that these three are the units of measuring temperature. Now we can say that temperature always we have to measure in degrees. So we can say that now in case of ice, if you are taking one ice piece, ice. Now its temperature we had already studied in the previous class. So we know the temperature of ice is 0 degree Celsius. So such a way we have to write 0 degree Celsius. So here now Celsius is there, we can represent it like this 0. Here now degree Celsius, in case of ice 0 degree Celsius. So we can say that unit Celsius we are mentioning like that, that is degree Celsius. Now Fahrenheit same way degree Fahrenheit. Now Kelvin degree K. That means we can write in capital letter. Such a way single letter if we are writing, we can write in capital letter. But if you are writing full word of Kelvin, then starting letter should be in small letter. Now here 0 degree Celsius. Now we can say that temperature of the boiling water we can see. Temperature of the boiling water. So that is equal to 100 degree Celsius. Similarly now Fahrenheit, instead of C, if we want other values we can write here 0 Fahrenheit, 100 degree Fahrenheit, now 0 degree Kelvin, 100 degree Fahrenheit, like that all different measures we can write. But normally in case of water we are measuring ice, its temperature that is 0 degree Celsius. Then here boiling water, its temperature we are measuring in degree Celsius, that is equal to 100 degree Celsius. But just I mentioned here, there are different types of units for measuring temperature, that is Celsius, Fahrenheit, Kelvin. But we need only now, that is degree Celsius. Now let us study with the other examples. So here now we studied the two differences, that is one is heat. Heat is a form of energy. Now how much heat we are supplying, as a result of it the body become very hot. More heat we supply, more hot that body will become. If we remove more heat from a body, more cold that body will become. We can say that ice, very cold we can say. At the same time boiling water, very hot. So we can say that this is very cold. This is very hot. Now, how much hot this body is there? How much cold this body is there? For measuring that, we have to use an instrument. That instrument is known as thermometer. Thermometer. Thermometer is the instrument or the device which we are using to find out the temperature of a body. Now even doctors are using for finding the temperature of our body. Now temperature of the water, temperature of the ice, for detecting that again we can use the thermometer. Now there are different types of thermometers are available. Now another thing what is saying here, now we people say what is the difference between temperature as well as heat. Heat here we have to supply heat, as a result of it the temperature of the body, or what we can say temperature of the body is of course increasing, at the same time hotness of the body is increasing. So temperature is the measure we can say. With the help of that we can understand how much hot the given body is there, whether it is cold, whether it is hot. For finding that we are using a measure, a measurement we can say, that is the temperature. So we can say that temperature, if we are defining temperature, we can say that temperature is the quantitative measure of degree of hotness or coldness of a body. Now there are different units of measuring temperature of a body. They are Celsius, Fahrenheit as well as Kelvin. Now we can say that the instrument which we are using for finding the temperature of the body, that is thermometer. Now we will study other type or other topic. Here I am using one container. In that I am taking ice pieces. Here full of ice pieces I am taking. Now I am supplying heat. Ice, all are knowing the temperature of the ice is 0 degree Celsius. Now as and when I supply heat to this ice, you can find that slow by slow we can say, the temperature, this ice pieces transforms to little water, slow by slow. Then as a result of it we can say that as and when the supply of heat is taking place, when we supply heat, that time this ice pieces absorb the heat. Ice pieces absorb heat. As a result of it, we can find that ice pieces changes to water. Now we can find that this process is taking place slow by slow, and full conversion of ice into water. For that more or less we can say that 1 minute to 2 minutes time will take. Till the time we have to keep on heating it. We all may be knowing at home, we people are getting milk packets. But milk packet if you are keeping inside the freezer, that will be fully transforms to solid milk. Whenever we want, that time when we take it and boil that hard, or we can say that solid milk. Slow by slow, that solid milk transforms to liquid milk. So that solid thing convert to liquid milk, it takes some time. Suppose 2 minutes to 3 minutes time. Similarly, we can say that here ice is there, that ice want to convert into water. So for that we are continuously supplying heat. Now for transferring this ice into full water, we can say that we are supplying heat. But you can find that when it is fully convert, that means from ice to water, we can say that this temperature will be, that means when this ice fully transforms to what? Water. Till the time same temperature maintained. We can say that here same temperature will be maintained. The same temperature which is maintained, that will be equal to 0 degree Celsius. Now one more thing, what is happening? When ice transforms to water, that particular time we are supplying heat here. We are supplying heat. Now this heat which it is absorbing, because it's a temperature not changing, temperature remain constant. At the same time, then what is happening? The how much heat we are supplying. So the heat energy what we are supplying, for that what will happen? So the energy what we are supplying, here we can say that heat energy we are continuously supplying to the ice for converting ice into water. So we can say that the supplied heat will have which, or what is happening to the supplied heat. So here ice, I am showing you here a piece of ice. In that molecules you can see ice molecules are there. Now as and when we supply heat, the bond means the connecting link between each and every molecules will separate. We can say that the bond between them will weak or weaken. We can say weaken the bond between them. Weaken the bond between molecules of the or of ice. So here this is the ice molecules. I am saying you ice molecules. They are more in touch with each other with more and more intermolecular force. They are having so much force is there. We can say that intermolecular force between the molecules of ice is very high. So between the molecules of ice, it is in solid form, so they are having so much intermolecular force is there, or we can say attractive force is there. Now as and when we supply heat, here temperature variation is not occurring till ice fully transforms to water. But at the same time you can find that the molecular force, or we can say intermolecular force, or the force of attraction, that weakens. Force of attraction weakens. Weakens means less become. Now one more thing. Here ice is there, here water is there. Now which is having more energy? Here ice has more energy or water has more energy? So of course water has more energy. Why water has more energy? Here ice has less energy. Why ice has less energy, water has more energy? Because here when ice heated, then water becoming. So we can say that ice plus energy, ice plus heat energy, that is water. Ice plus heat energy, then water is becoming. So we can say that water has more energy than ice. Now other question. When water is heated, then that transforms to gas, or we can write as water vapor. Only vapor I am writing, or water vapor. When we heat water, What is forming? Water vapor is becoming. Water vapor is becoming. Now we see here, water has less energy. Water has less energy. At the same time, water vapor has more energy. Now here we can say that why water has less energy? Because when we heat water, then water vapor is occurring. So we can say that water plus energy, that is water vapor. So because of that, water vapor has more energy than water. Now here, we started to heat. Now we can say that at 0 degree Celsius, ice is there. Same thing we are heating. At last, first we can find that little means the conversion is occurring. Then slow by slow, full ice transforms to water. When full ice transforms to water, then only you can find that the 0 degree Celsius transforms to 1 degree, 2 degree, 3 degree. Like that way we can find the temperature variation. Once full ice transforms, till the time the temperature of the ice plus water, that will be 0 degree. Temperature of the ice alone will be 0 degree. Temperature plus ice, temperature of ice plus water, that also will be 0 degree Celsius. Only water become, then we can say that its temperature, as and when we keep on heating it, we can find that temperature of the water keep on increasing. Finally, its temperature reaches to 100 degrees Celsius. Once its temperature reaches 100 degrees Celsius, then further increase in the temperature won't be there. At the same time, you can find that this water, slow by slow, once it started to boil, then you can find that this water transforms to water vapor. Steam we can say, water vapor or steam. Now, when this water fully transforms to water vapor, till that much time, we can say that the temperature maintained, the same temperature will be there. When the temperature of the water fully transforms to water vapor, till the time we can say that the temperature of the water vapor as well as the water will be 100 degrees Celsius. So we can say that here, ice to water, temperature will be 0 degrees Celsius. Now, temperature of the water to full transformation of water vapor. Water vapor I am writing here, water vapor. We can say that again temperature maintained, that is equal to 100 degree Celsius. Now, here we people studied about which one? The conversion. That means ice to water as well as water to water vapor. So there how the temperature is maintaining, you people studied. In case of ice to water, when full water formation will be there, till the time the temperature remain constant. Temperature remain constant. That word is very important. Temperature remain constant. We can say that ice to water, temperature remain constant, that is 0 degree Celsius. Again we are continuously heating. So water to water vapor full. When water fully transforms to water vapor, again we can say that that temperature is 100 degrees Celsius. It maintained, it remains constant. Now, one more thing is there. Conversion of ice into water. Conversion of ice into water, and you are studying conversion of water into water vapor. Two things you studied now. Conversion of ice into water, as and when we supply heat, so we can say that that is happening at 0 degree Celsius. This is known as melting point of ice. Melting point of ice. melting point of ice into water, that is 0 degree Celsius. So as and when we supply heat to the ice, slow by slow ice transforms to water. So we can say that ice melt over there. So that temperature, that is at 0 degree Celsius it is happening. So we can say that what is the melting point of ice? Melting point of the ice is 0 degree Celsius. We can say that the constant temperature at which ice transforms to or ice converts to water, that is known as melting point of ice. Now what is meant by boiling point of water? The temperature, the constant temperature, fixed temperature we can say. This is going to happen at 100 degrees Celsius. So we can say that the constant temperature at which water transforms to water vapor is known as, that means we are keep on heating the water. Then once water starts to boil, then at that boiling time, you can find that 100 degrees Celsius boiling process will take place. As and when water starts to boil, you can find that steam formation or water vapor formation is taking place. So we can say that at 100 degrees Celsius water starts to boil. So that temperature is known as boiling point of water. So we can say as and when we supply heat, a constant temperature at which water starts to boil, the boiling temperature of the water is known as boiling point of water. Now we will study latent heat. What is meant by latent heat? With the help of example we will study that. Now here 3 substances I am showing, that is ice, water and water vapor. Now we are studying what is latent heat. Now latent heat means it is a constant temperature. Latent heat means it is a constant temperature at which all changes are occurring, that I will show now. Here ice transforms to water. Ice transforms to water. This is happening at 0 degree Celsius. Again here water transforms to ice. That is again happening at 0 degree Celsius. So here we can say that ice transforms to water. That particular time ice absorbs heat. Ice absorbs heat. Here when ice transforms to water, that particular time we need to supply heat. So we can say that as and when we supply heat, ice absorbs heat. As a result of it, at the constant temperature, fixed temperature, ice when it is fully transforms to water, till the time the constant temperature maintain, same temperature remains. Now again when we transforms water to ice, that means we need to cool water. So we can say that at that time water removes its heat energy. Or from water removes heat. Then we can say that this water at 0 degree Celsius transforms to ice. So here we can say ice absorbs heat for transforming or converting from ice to water. Process is taking place at 0 degree Celsius. We can say that constant temperature. Again water when we cool it, removes heat means we have to cool it. For that only we people are keeping it inside the freezer. Normally water we people are keeping it inside the freezer. So that time we can find that this water transforms to ice. So when water cools, so inside the freezer we are doing, at that time which process is happening? Freezing process is taking place. Inside the freezer, freezing process is taking place. As a result of it, you can find that water transforms to ice. The temperature again same, that is 0 degree Celsius. Now we are coming to here. That means when we heat water, we can say that we are supplying heat here. I am mentioning here now. So we can say that at 100 degrees Celsius, this water transforms to water vapor. So here we can say that we are supplying heat. Now at 100 degrees Celsius again, when we, water vapor means a gas, it is gas. Now when we cool water vapor, again at 100 degrees Celsius, the whole water vapor transforms to water. So we can see the two-side arrow I mentioned here. One side arrow that is for heating, this towards this side arrow shown that is for cooling. Or we can represent in other way also, water this side, then ice, one side arrow, water. Again when we are cooling it, that particular time such a way one more arrow, then this kind of arrow. So this or this, both of them are same. Here we can say that this is happening 0 degree Celsius. Again water to ice, this is again happening at a 0 degree Celsius. So we can say that the constant temperature at which a substance, we can say that solid changes to liquid and liquid changes to solid. So a constant temperature. Again we can say that at constant temperature in which a liquid changes to water vapor or gas, and at the same temperature gas or water vapor transforms to water. So we can say that for the conversion of a substance, here now we have to study either this or this. So we can say that a constant temperature at which a solid substance transforms to liquid or a liquid substance transforms to solid, that is known as latent heat. Now here, a constant temperature at which a liquid transforms to gas, or a constant temperature at which the gas transforms to liquid, that is known as, that constant temperature at which that process is taking place, that is known as latent heat. Now here, cooling process will be taking place, then we will say that latent heat of fusion. That means a conversion of, we can say that conversion of ice into water. At constant temperature it is taking place, latent heat for common ice. Now here, when ice transforms to water, then we will call it as latent heat of fusion. Latent heat of fusion. Here, at constant temperature, ice transforms to water, or we can say at constant temperature. Here also same way this process we can say. So here fusion process is taking place. So normally at constant temperature in which ice transforms to, this is fusion for ice to water. We can say that in the form of one graph I will show you now. Before that one more definition we will study. So here now what is meant by latent heat of fusion? Three things are there: latent heat of fusion, latent heat of vaporization, vaporization will be U won't come. Vaporization. Vapor means a U will be there, but vaporization place no U. Then latent heat of freezing. So here latent heat of fusion means conversion of ice into water at fixed temperature. Now latent heat of vaporization means conversion of water into vapor at fixed temperature. Now latent heat of freezing means conversion of water into ice. This process is taking place inside the freezer. Why? At a 0 degree Celsius only it is happening. So we can say that that is known as a latent heat of freezing. Here a graph I am showing. This particular point, both the sides 0 I am mentioning. Now afterwards here 10, 20, 30 degree, all degrees, 40 degree, 50 degree, 60 degree, 70 degree, 80 degree, 90 degree, then 100 degree. Here now time, this is a temperature. We can mention in degree Celsius. Now here time in bracket in minutes. The time is showing in minutes here. 2 minutes, 4 minutes, 6 minutes, 8 minutes, 10 minutes, 12 minutes, 14 minutes, 16 minutes, 18 minutes, 20 minutes, 22 minutes, 24 minutes, 26 minutes, like that it is extending. Now here at 0 degree Celsius, both the sides 0 minute here, here 0 degree Celsius is there. Now as and when here till this much time, till 4 minutes I can say, here 0 degree Celsius is there, that means ice will be there till 4 minutes. You can get ice plus water here. So here once the temperature, once we started to heat, that particular time we can find that till 4 minutes time the temperature remains same. That means here 0 degree Celsius is there, here 0 minute is there. This is showing that 0 degree Celsius, this is the 0 minute. Then after that when we people are supplying heat, but even though there is no rising heat, if rising heat is there then the graph will rise. But here same straight line the graph is moving. That shows that here no rise in temperature till this ice transforms to water. Now we can say that here formation of water became. Just imagine at this temperature, at this time the temperature, the ice fully transforms to water. Once water formation is occurred, then we are continuously heating only. As a result of it, you can find that the temperature of the water keep on increasing till its temperature reaches up to 100 degrees. It will be a straight line. We can say that here it will be a straight line graph. Straight line graph it is. So you can find that here the time keep on increasing once the time 22 minutes reached. We can say that here the graph grown or graph straight condition it is gone. Then afterwards we can say that from here this 100 degree temperature dotted line represent once it reaches here 100 degree Celsius temperature. So we can say that this temperature is equal to now 100 degree Celsius. At this temperature water starts to boil. Water starts to boil. Then you can find that once it starts to boil then temperature remain constant. Till when this temperature remain constant? Same way 100 degree Celsius temperature maintain once it is fully transforms to vapor. Vapor means water vapor. Once it is fully transforms to water vapor, till the time the temperature maintains. So we can say that here now approximately here 20 and 22 in between. We can say that here 100 degree Celsius reached. Then we can say that here we can mark now this starting point we can mark as A, upside I am writing A, here now till 4 minutes that I am writing B. Now we can say that for the conversion of ice to water taken 4 minutes, approximate reading only written 4 minutes time. Afterwards again we are continuously supplying heat. As a result of it, once 100 degrees Celsius temperature become, that particular time you can find that water starts to boil. Once it reaches 100 degrees Celsius, then the temperature remains constant. After that there won't have any rise in temperature. This 100 degrees Celsius remains constant. At this constant temperature, you can find that this water transforms to water vapor. So A, B, here I am writing C, then this point I am writing D. So this is known as temperature time graph. What is regelation? Regelation. R-E-G-E-L-A-T-I-O-N. What is regelation? Regelation is the property or a phenomenon that is happening in ice. Ice piece. Here I kept this is one table. On that one support I kept. On that I kept one piece of ice it is. Ice. Ice block I can say. Rectangular shaped ice I kept here. Now this is having a rectangular shape. So here regelation means what? It is a phenomenon. It is a fact. It is a reality. It is a phenomenon in which. Now what is happening? Here I kept one ice piece on this block of wood. Afterwards I taken one copper wire or any metallic wire. We can say iron wire also we can take, or copper wire, thin wire we have to take. Then that thing I kept on this ice piece. Then after that, from this thing through that side, table is there now, just imagine like that way, table top is there. On that such a way ice piece is keeping through both the side. Such a way I am passing one thread. Just imagine thread. But here this is a metallic thread. Then both the ends I am tying to weights. So here its other end also will come here. Two ends are coming. This thing we are passing through that side. Then two ends very heavy weight I am hanging it. Two are very heavy weight we can say, 1 kg weight, like that way, heavy weight. Both of them are weight, 1 kg, 1 kg I am writing here. 1 kg, again this is also 1 kg, equal weights. Both the side you have to hang it equal weight. So 1 kg weight here, through other side also 1 kg weight. So we can say that like that way, table is there. Here one support we are keeping, on that we are keeping the ice piece. Then through both the side we have to hang to weight. That weight approximately 1 kg weight I hanged. You can find that as and when we people are hanging two weights after passing one copper wire or iron wire through that ice, here pressure is exerting. So we can say that here phenomenon in which what is happening? Conversion of ice into water takes place by exerting pressure, we can say. So here what is happening? With the help of this heavy weight here pressure is exerting on this ice. As a result of it, you can find that this metallic wire penetrate. Penetrate means pass through the ice. Penetrate through this metallic wire penetrate. Penetrate means pass through the ice. Penetrate through the ice. When it is penetrating through the ice? Because as and when heavy weight, we people are hanging on this ice piece. So we can say that pressure is exerting on the ice. As a result of it, you can find that this copper wire or iron wire penetrate through it, pass through the ice. Then till when it will pass? The whole ice when it is completing. So we can say that the ice piece now, here one piece become, here again other piece will become. Such a way it will pass through. So here one piece we kept, now you can find the two pieces. But one important thing, you can find that as and when it passes, here you can find that this much, here ice is there, now this much thread passed. Now like that way, as and when it come down, so you can find that upper part again forms ice. So that means till this ice piece fully won't transform to two pieces, upper part separates, you can find that this copper wire fully passes through the ice. But as and when it passes, you can find that upper part, some distance it is passed now, penetrated, passed through it. So where it is passed, that part again transforms to ice. Why? Once the pressure releases from there, once the pressure goes, then we can, or removes from there, then again it transforms to ice. But you can find that the thread fully comes out. That means from upper part it is slowly penetrates. Then at last you can find that the copper wire or the iron wire comes out from this ice. At the same time, again you try, already this thread is or the wire passed out. So when we try to open with our hand, already cut occurred. So we will think means two pieces became, but never. Such a way separate piece is not becoming. Why? Not becoming. Why? Because once it is penetrating the upper part, again its pressure gone. Again pressure is moving downward. Why? Because weight is going now downward direction. So once cut is occurred, afterwards it is moving downward direction. So here upper part now no pressure. As a result of it, again it is joined and it become again ice. Once the pressure reduces, again it transforms to ice again. This process is known as regelation. So here we can say that what is meant by regelation? The phenomenon in which conversion of ice into water by exerting pressure. And this process, once as a result of exerting pressure, what is happening? Ice converts to water. Again what is happening? Again this water turns to ice once the pressure removes. Again water transforms or converts to ice as and when pressure removes. Or we can say when there is no pressure, again we can say that this water particles again join and it become ice again. So this process we can say as regelation. As a result of regelation, one important thing we can say that you cannot be able to separate and remove ice into two pieces. Why? Because again as and when here pressure reduces, again it join back, again it will become ice again. Thank you.